Gorilla Glass, a strengthened glass for electronic devices, was first developed by Corning in 2007. Today, it is used in more than 3 billion devices all around the world. What makes Gorilla Glass so much stronger than normal glass? The most commonly used glass is soda-lime glass, which is made by melting silicon dioxide, sodium oxide, calcium oxide, and a few other materials at a temperature of 1,675 degrees Celsius. When cooled, the silicon and oxygen atoms form covalent bonds with each other, creating an amorphous solid. Glass is amorphous. This means that it lacks long-range order, making it brittle and easily cracked, as its layers cannot slip over each other in the way that crystalline solids like graphite would. Within the amorphous solid, positively charged sodium ions form ionic bonds with the negatively charged oxygen ions. These sodium ions are not tightly packed into the amorphous solid. In fact, there's plenty of space around each sodium ion. The difference between soda-lime glass and Gorilla Glass is that instead of having sodium ions trapped in the oxygen-silicon matrix, Gorilla Glass has potassium ions. This change in the atom type has many positive effects on the strength and utility of the glass.
Without a doubt, the one key design property of Gorilla Glass that has made it most widely known is its durability due to its molecular composition, giving it high scratch resistance and high Vickers hardness test ratings. In the last decade, Gorilla Glass has released 4 different generations of its product, each time advancing its technology to improve its damage resistance, becoming more flexible and reducing its thickness while not sacrificing strength. The most recent generation of the product, Gorilla Glass 4, withstands drops on rough surfaces 80% of the time and is up to 2 times better than competitive aluminosilicate glass designs. Soda-lime glass, which is what is typically used, rarely ever survives drops of this magnitude. Gorilla Glass has many rivals due to the competitive nature of the industry.
Gorilla Glass is working on making its product more scratch resistant in order to compete with GT Technology's sapphire glass, which is made of synthetic sapphire.
How does Gorilla Glass provide the strength they are known for? One key step in their production process is the ion exchange process that chemically strengthens the Gorilla Glass. In that process, the sodium ions in the structure are exchanged with potassium ions. This is effective because potassium ions are significantly larger than sodium ions. While sodium ions have a van der Waals radius of 227 picometers, potassium ions have a van der Waals radius of 280 picometers. When the glass is immersed in the hot salt ion exchange bath, sodium's ionic bonds to the aluminosilicate break, while potassium is able to maintain an ionic bond at higher temperatures. So the sodium ions in the glass structure basically get pushed out by potassium ions. The much bigger ions in the glass make its structure much more densely packed. Therefore, they create a deep compression layer on the surface of the glass. This strong, dense layer makes the glass less brittle. What's unique about Gorilla Glass is that because of its inherent composition, it can allow the larger potassium ions to penetrate the surface more deeply than other glasses, so that the ions create a larger protective compression layer. The compression layer of Gorilla Glass is 5 times deeper than the compression layer of soda-lime silicate glass. This feature increases Gorilla Glass's ability to tolerate compression and deeper scratches.
Corning has managed to dominate the field by perfecting its formulas to increase the crack initiation load threshold while keeping the cost low. They've done this by determining the 3 following rules. 1. This inequality dictates the density of the glass, and higher density makes glass more damage and crack resistant. Aluminoborosilicate glass is denser if it has fewer non-bridging oxygen atoms, and this ratio minimizes the number of non-bridging oxygen atoms when it is greater than 1. 2. The mole percent of potassium ions should not be above 4%. While at small amounts, potassium ions can increase the depth of the compressive region. When it is at a mole fraction greater than 4%, it actually decreases the depth of the compressive stress region. 3. The mole percent of silicon dioxide should not be above 72%. This is because silicon dioxide is very viscous and has a high melting temperature, and so makes the glass mixture hard to work with and requires a lot of energy to melt. With these advanced technologies and trade secrets, Corning's Gorilla Glass is the leading cover glass for electronic devices.